In this hopefully short video, I'm going to just briefly touch on the abstracts and conclusions for the engineering reports that you'll write in year 12 engineering studies. So I've got a couple of points where I want to talk about abstracts and conclusions, or the conclusions in particular, and an analysis that you will do as part of your report. So first of all, I'll just point to the report guide that I recommend as part of the assessment criteria, which does talk about conclusions in point 7, and it refers to it earlier when talking about the format. So this is the document, a guide to writing an engineering report by Bob Weiwei at University of Wollongong, and here we go. Conclusions. The conclusion of a report must be related to and resulting from the material that appears in the report. The conclusions must not introduce new material. An example of conclusions is given in the end. Okay, so we're going to look at that. So I'm going to give, before I go into detail, and I will scroll down to that part, but before I go into detail, I'll go back to my document here and say that the abstract and the conclusion are the most important parts of the document. Many people, including myself, when I want to look up a scientific study, I often don't have the technical expertise to understand the research, and if I want to get a general idea of what the end point of that research is, and also to see whether or not the report is worth investing the time to read the rest of the document. Maybe it's not related to the thing that I was looking for. What I'll look for is the abstract and the conclusion. So what the abstract does is it sets up the conditions. This is the thing that we're trying to do. This is the goal of the research. Now, often the abstract will give a very vague results of the findings, but not always. And at the end of the document, after they've gone through the methodology and considered limitations and things, they'll then finally have a conclusion. Now, the conclusion is where you can go to hopefully get a very good idea of where the researchers, I don't want to say the conclusions they came to at the end of their research, because that would be a little redundant, but that is really the end point of their research. That when they finish, when they dust off their hands, how did they feel about the research? What did they find? And what direction are they going to go to? Where do they think this thing is applicable? Okay, so before I go to conclusions, because the conclusion should be the last part, I want to talk about analysis. Now, I've asked for analysis after the results of the experiment. So I've asked people to provide the results of the experiment. I asked for the methodologies, and in the case, depending on the report, I asked for different specific details, but I always ask for some form of methodology. I asked for results, and then after the results, I asked for an analysis. Before I get to the conclusion, now the reason I say that is the conclusion should only report on things already discussed in the report. It should be a summary. It's like the last paragraph of an essay. Whereas the analysis, on the other hand, the analysis is a place where we can talk about things that don't necessarily relate to the experiment, and certainly the things that don't necessarily relate to the experimental results. So in the examples of what we do in our engineering reports, well, first of all, we want to talk about what does the word analysis mean. So analysis is one of the HSC keywords. So we have a glossary of keywords. You can search this without too much effort. And analyze is the second one, and I've got it written down here, I've copied and pasted it, which is identify components and the relationships between them, draw out and relate implications. So in this case, obviously we don't mean the physical components of the project, so I guess it could be, but we're certainly talking in a much broader sense of that. We're talking about all the things that come together to impact and affect our research and the environment in which it's applied. And we want to look at relationships between things. We want to look at the implications of our research. This is the key. I really want to talk about the implications, how these things are going to be used. Okay, so just to look at a couple of examples. In your research, you might have used the same material. Now, at some point, you might have referenced why you wanted to use that specific material. In your analysis, you should probably talk about why you chose that material. Right? How suitable is that material in a real-world application? Maybe that material is the perfect material for you to use as a Year 11 or Year 12 student, but it's in no way suitable for a full-scale engineering project. Now, I don't want to go into all of these in too much detail because there's a reason why I only mentioned some things in class, because I need to use my assessment tasks as a grading mechanism, and if I give everyone the answers, I'll just have 15 assessment tasks that look exactly the same and have to give everyone 100. But some of the things that I've already discussed in class are the design used. So the fact is that most people in, say, their civil engineering report talk about trusses. Most people, and we strongly urge to use a truss design. But the fact is, and I don't want to go into too much detail, that trusses are not widely used in real-world applications anymore. So this is a good opportunity to talk about that in the broader sense. Now, we do talk about that in the early research part of your engineering report, but this is a point where you want to talk about how your end results relate to real-world implications. So I've talked about joints. So some people who have listened in class might know about fixed and pin joints, and they might be able to apply what we've done in our course and compare it to the findings of, say, other 3D models that we might have used, other modeling software that we might have used. Testing conditions and the limitations of our testing conditions are very important. Obviously, we're not using a lab, and a lot of the time, the experiments you're doing, you might have identified problems in your own research. You might have said that if this was our methodology, this is what we plan to do, but we've identified during our resource, these are things where we know that there are holes in our experimentation method. These are things we could have improved. There's also the consideration to experimental procedures, so not just accuracy, but also concepts which I'm not going to go into here, like blinding. And these are things that you can talk about. Now, before I finally go back, and I'll point, I won't read through the WeWay example of conclusions. I will just stress that this is a high school task, and I would urge most students who are watching this video that they probably shouldn't stress that this is not going to be the thing that makes or breaks whether or not you pass or fail, but this is the area where I can try to differentiate between students who have applied themselves and done things beyond what the bare minimum of what they've been asked or what they've been led to do, and where they've applied themselves and done their own independent learning and demonstrated knowledge, where they've considered what their research actually means in a broader context, and some of the ways that their research could be improved. That's really the keys that we want to think about in our analysis. So finally, with our conclusions, the conclusions really should just wrap up what your findings are. So they want to give something, a guideline that this will be the paragraph that you'll use when you're when people look at your work and when people want to refer to your work. This is the part they're going to talk about. This is going to be this is the part where you're going to say studies have found, and this is the part that you want to talk about. You want to say this is the thing that I learned as a result of my testing. Now, in some cases, your testing may have gone horribly wrong. You may not have had any successful testing. All of your trusses might have failed in unusual ways, or ways that are not very indicative. And this is where you want to look at your failing and talk. This is where you want to write the report. I'm going to backtrack to one point that I just considered, which is in part of our analysis. Is a key part of analysis is investigating the type of failure and identifying whether or not it matched your predictions. So that's a key that you want to look at. But once you've done that analysis, you want to, a very common thing in giving a speech, and this has not been a great example of that, but I'm tired, I've just come back from an excursion, and the key in public speaking is tell people what you're going to tell them, and then tell them again. And this conclusion is the part where you tell them again. This is the part that most people are going to read. They're going to read your introduction, and they're going to read your conclusion. This is where you're going to give a summary of all that good work you've done. It should not introduce any new content. It does not need to be particularly long. Hopefully that will be some assistance to you, and good luck.